Good day everyone, you are welcome to my channel. On today's class, I will be treating subject on physics and my topic is electric field. I am Giwa Alim Kende. Topic outline. I will be taking you through 3 topics under electric field. Electric field, properties of electric field, and Ohm's law. Lesson objective. At the end of the class, you should be able to define electric field, list the properties of electric field, state Ohm's law, define Ohm's law parameters. What is electric field? Electric field is a region around a chained particle or object within which a force would be exerted on other charged particles or objects. That is, a force, a change in particles or object within a force. When a force of attraction or repulsion is effected on object, whereby positive and negative charges are either going to attract or repel. In this region, we tend to regard it as electric field, where electric charge is going to be produced. In another word, electric field is an electric property associated with each point in space when charge is present in any form. Mathematically, electric field is given as E equals to F all over Q, where electric charge equals to force all over charges. SI unit equals to Newton per Coulomb. The direction of the force depends on the signs of the charge and the direction of the field. For a positive charge, opposite to it for a negative one. And properties of electric field. Lines that indicate the strength and the direction of the electric field. The more dense the lines, the stronger the field. And 2, electric wave vectors are tangent to the curve. Looking at the diagram, you will see that positive charges move to a direction and negative charges move to opposite direction, and charges will continue to move on this regard, and when they attract in the what? In a direction facing each other once they are opposite charges. Ohm's law. What do we understand by Ohm's law? Ohm's law states that the electric current passing through a conductor is proportional to the voltage and inversely proportional to the resistance. V equals to IR, where V is the voltage, I is the current, and R is resistance. Now, let's understand each parameters of Coulomb's law. Number 1, voltage. What do we understand by voltage? Voltage is the pressure from an electrical circuit power source that pushes charged electron through a conducting loop. It can also be defined as the difference in electric potential between 2 points. It is a phenomenon that determines how much electric charges want to move. That is, the charges that want to move, that you want to produce, how much they will move to create a current. This is a phenomenon that determines the movement or the rate or the willingness of the electrons to move through a circuit to produce a current. Voltage can be conceptualized in 3 ways. What are the 3 ways? High voltage, low voltage, and zero voltage. A good example is when you have a wall clock using a dry battery. When you put the battery at fresh, the clock starts working perfectly. But as the time goes on, that is high pressure, high voltage. As the time goes on, the battery starts reducing, whereby causing the clock to not work perfectly. You might be having shortage or a substandard clock calculation. In this case, you are having a low voltage, and at the point in time your clock stop working. In this case, your battery can no longer push out electrons that will create a current to run the clock, and then we have a zero voltage. Voltage is measured in volts, and the symbol for voltage is V. Type of voltage. We have 2 types of voltage. 1, alternating current voltage, and they are commonly produced by generators, materials that rotate or like windmill and the like, we call them alternating current voltage. And the second one, direct current voltage. Sources of such are materials that have two terminals, positive and negative, like the battery your wall clock uses. They are direct current voltage. And that is a good diagram explaining the two different voltage, your generator and your battery with two terminals. So whenever you see a source of current that have two terminals, then you know you are working on direct current voltage. Current. What is current? Current is the rate at which electron flows past a point in a complete electric circuit. It is the measure of how much electricity is flowing in a medium. Current is conceptualized in two ways. What are those two ways? High current and no current. I'm very sure you will have heard about that before. When you ask, are we having high current or we having low current? That is the basis. And now you know as a physics student. The symbol for current is I and it is measured in amperes, amps. A good structure explaining a copper wire as a means where current flows through, having positive terminal and negative end. Resistance. Resistance is a measure of the opposition of current flow in an electrical circuit. It determines how difficult it is for electricity to move through a material. A good example is this. If you have two pipes where water can run through, one is filled with sand or stone and one is not filled with anything, which one do you think will allow free flow of water? Definitely the one with no stone. The one with stone serves as a resistance, resisting the free flow of water, and this is what our resistance does in an electric circuit or electric field. They oppose or reduce or hinder or resist the flow of current passing through a medium. And resistance is measured in ohms, symbolized by the Greek letter omega. Conductors offer very little resistance, while insulators are materials that present high resistance because they don't allow the flow of electron to flow through a medium because they are what mostly insulators. Then you will know resistance are what mostly insulators. Summary of our class today. Electric field is a region around a charged particle or object within which a force will be exerted on other charged particle or object. Ohm's law states that the current passing through a conductor is directly proportional to the voltage across the 2 points. The parameters of Ohm's law are voltage, current, and resistance.